Yeah, perfect.
All right, so I'm sorry, audience, for this interruption, but we do have time, I hope, sufficient time for you to continue this presentation. Yeah, thank you very much, Ernesto, for introducing me and on this topic, dealing with the atmosphere of Starry Night as pictured by Vincent van Gogh in 1889. And the idea of this talk is that to give some more information on particularly on the motions Vincent painted in his famous painting Starry Night. Well, Starry Night was actually painted in 1889 by Van Gogh when he was in Saint-Rémy-de-Provence in southern France, in the province part of France. And the painting shows clearly motions across the sky, which are streaming over a village and the surrounding hills. It's also quite visible that light is reflected by the moon and emitted by the stars is twinkling when it passes through the atmosphere. This is the moon, of course, obviously, and this is the morning star, which is the Venus star, as well as the Pleiades star cluster, which is visible here as well, as many other stars painted by Vincent. Vincent became particularly interested in painting of night skies when he moved to the southern part of France around 1888, 87, and where he stayed till 1890. And as you can see in the Café Terrace at night at the Arles, which is located, the painting is now located in the Netherlands, as well as the Starry Night over the River Rhone in 1888 and a country road in the Provence. These are particular pictures of paintings of nights. And he also has a painting of the White House with not a yellow house, which is at daytime, but a white house, which is at nighttime. And you can see in all these pictures, paintings, you can see the twinkling of the stars in the night sky, which was apparently very much of his interest. Now, in 1889, Vincent struggled with mental illness, and he often hallucinated and suffered attacks, and in which he sometimes also lost consciousness. And during one of his attacks, he used a knife and cut off a part of his ear, or in some pictures, literature says that he even cut off his full ear. But later on, he could not recall anything about this event. And the question is, of course, how much has this troubles impacted on the creation of Starry Night? And is perhaps the painted atmosphere an hallucination, or at least influenced by hallucinations? And just for your information, Starry Night was actually not directly painted when Vincent was looking at the sky, but he painted later on during the day after having seen the skies in the morning. In the southern part of France, when he was located in the asylum in southern France for the treatment of his troubles and disease. And this Saint-Rémy-de-Provence is about 20 kilometers south of Avignon, so it's really in the Provence. But also is also influenced by the mountain range, what's called the Alpilles mountain range. And here you can see actually what we know at the time of June 1889, how the stars were located in the sky relatively in southern France, the moon, Venus, as well as the Pleiades cluster range, cloud range of the star range. And you can see that the sun is just below the horizon still. These Pleiades are known to have twinkling stars. This is a star cluster. There's a couple of stars which are connected, but on a large distance, of course, they appear as just as one star. But more important, this twinkling of the stars occurs due to refraction of light in the atmosphere. particularly when the atmosphere has different layers with different temperatures. So there's a real physical effect. And in fact, Vincent was impressed by this, but in a letter to his brother about Starry Night, he said, yeah, I was just study a night sky when he was painting this. But it's clearly visible, these motions on the painting, these turbulent, this wave type expressions resemble to what is known as turbulence in the atmosphere, irregular motions which have a larger scale motions up to very smaller scale motions which can occur in the atmosphere. And is this something which Vincent really has seen this, or is this also an imagination because of his turbulent state of mind? So the question is, to what we are like to answer here is, to what extent has he really seen or represented at least atmospheric turbulence? It's difficult, of course, that to see such a skies. I have never seen such a skies in Holland, which is a relatively flat country, but perhaps in the southern part of France and other parts of Europe where you have more mountain ranges, you could actually see this breaking of waves in the atmosphere which are creating turbulence. Now, there are several possibilities of atmospheric turbulence. The typical turbulence, which many people are familiar with, is the turbulence close to the Earth's surface in the lowest part of the atmosphere, let's say in the lowest 1 kilometer during daytime, and lowest 100 or few hundred meters during nighttime, where the turbulence is caused by friction of the wind over the Earth's surface, over the mountain, or even over a flat surface. That can happen too. And during daytime, it can also be enhanced by clouds, cumulus clouds, or even deep clouds, which are present, given here on the right side of the picture. But in a mountain area, the waves which are omnipresent in the atmosphere can actually break up in what is called clear air turbulence. And this clear air turbulence is also visible or sometimes apparent higher up in the atmosphere, in particular on the level where planes are flying. And the pilot then, if that happens, the pilot warns the passengers for having clear air turbulence. So that's basically the breaking of waves in the atmosphere, which are always occurring, but in certain circumstances they can break up and create irregular motions, which we know as turbulence. Now, there are quite a few studies in the literature about the Starry Night, and particularly also on the atmospheric properties of turbulence. And I picked out two, which have somewhat conflicting conclusions. Now, first one is by Aragon and cohorts, which was published in 2008, which actually analyzed the light of starry nights, and on basis of light properties, they concluded that the structure of the starry night waves, which are the motions which are depicted, are resembling the mathematical structure of turbulence as you can see in fluids, like in the atmosphere. While a more recent study, actually by doing a somewhat different way of analyzing the painting, came to a conclusion that it's actually not so much fulfilling all the properties of atmospheric turbulence. Now, important is that with this luminance, which was analyzed by Aragon et al., you can actually, for any surface, you can analyze the light, the brightness of for instance, of the painting. And then if you then do the luminance, is then defined as the intensity of the emitted light from a surface in a certain direction. And it's in fact a measure on how bright the surface will appear. Now you can then analyze for any picture or painting, you can analyze how strong the brightness is of a particular point in that painting, or with the so-called RBG, which is a combination of red, blue, green, and blue components. And you can give that a numerical value. in an objective way. And then, and in addition to that, you can then, between all the points of in the picture, you can create then, calculate the difference in this luminance on these RBG values, and plot that as a function of the distance between the pixels, between the points in it. And that's seen at the right-hand side in this picture for various scales and analysis in the painting. Let's focus on the red one, the lowest curve, that actually shows a so-called frequency distribution, a PDF, probability distribution, of these brightness, the difference in brightness between different distances in the painting, as it could appear by analyzing, as it appeared by analyzing Starry Night picture. And that resembles the properties of atmospheric turbulence and turbulence in general, because you can also do a similar job by analyzing velocity differences in flows, to real turbulent flows with motions on various scales, and then you find a very similar way, properties for the frequency distributions, as is depicted here at the left-hand side for velocity differences, and then the right-hand side for the light intensity in the painting, Starry Night painting. Now, the other study did actually a more direct analysis of properties of the flow, which you can do by analyzing, which is known as the turbulent kinetic energy. So how much energy a certain motion in the atmosphere can have as a function of its size. And that's, so larger eddies, the largest motions, have most of the energy, and this energy is then transferred to the smaller and smaller scales, to the smaller eddies. And during this transfer of kinetic energy in the atmosphere, the energy is transferred, but is not so much dissipated. Ultimately, the kinetic energy, which is created at a larger scale by motions in the atmosphere, is dissipated by molecular effects at the very small eddies, or which have the largest wave numbers. A wave number is just the other way, just 1 over the size of the eddy is called a wave number. And more importantly here to remember is that from theory, defined, introduced originally by Kolmogorov already in 1941, he shows that this should give a slope of -5/3 in these energy spectrum. Well, then Finlay in 2020 analyzed also with this RGB colors the spectra in the part of the Starry Nights which have this strong motions, which is depicted here in the upper right corner, and came up with this blue line as a result. So the spectrum is giving from the largest scales to the smaller scales, like the blue line. And actually the red line is an approximation for that, for this inertial range. And that gives a slope of -1. So not -5/3 as you would expect if it would be fully turbulent flow. So on basis of that, he concluded that this Starry Night is not showing real atmospheric turbulence. It does show this larger scale motions, but not fully the properties of atmospheric turbulence. Now, this, as mentioned earlier, this turbulence can occur in mountain areas on elevated levels by the breaking of gravity waves. And these waves are omnipresent in the atmosphere. And at certain combinations, they can break up and create these irregular motions. And then this can also enhance the twinkling of the light of the stars, which are the light which passes through the atmosphere, because it influences also the temperature and the density. And these gravity waves are actually very important, not only just to understand turbulence, but also as part of the development of weather systems in addition to many other processes which can occur in the atmosphere and which need to be represented by in weather and climate models. So in summary and conclusion, the motions as seen in the atmosphere of Starry Night do seem to resemble real turbulence, and I think it's mostly likely due to breaking gravity waves. There's not a complete agreement in the literature on the turbulence properties, as we have seen, and it's also not completely clear if you can actually observe this in reality, if just by twinkling of light through the atmosphere. But at least it's surprising that the picture, the painting, which was painted by Vincent, is so similar to what we know from atmospheric turbulence. And I guess that is recognized and by many people, and also gives rise to a lot of appreciation of the Starry Night and of this painting in particular. Now, you can find much more information and also nice animations and supporting videos on the internet, as the one I show is a low and in the lower value here by Natalie Sinclair on YouTube. And actually the link of that is given on this slide. But overall, Starry Night has become a very popular and iconic painting by Vincent. And these days you can also buy puzzles, even of the Starry Night, which is, now this particular one had 1,000 pieces, and it was a hell of a job to create. And actually, I got this as a present when I said farewell to EMS as a president, and they gave a lot of homework, and actually, due to the help of a neighbor, the puzzle was finally created. So maybe that's a nice thing to conclude, that Starry Night is still puzzling me. Thank you very much.
Thank you very much, Bert, for this nice and motivating presentation. And now we'll move to the questions. Remember, you can either use the chat or raise your hand. Please, Vesna, will you read the first questions?
I cannot see any question in the webinar chat room.
Okay, in that case, I've got one question in myself. Could you tell us something about the background of Van Gogh on science or on observation of nature? I mean, because this description of turbulence seems that it has behind someone very familiarized with the physical principles of turbulence. Could you say something on his background?
Yeah, actually, I was puzzled by this myself. What I could find on his biography is that he was born in 1853 in the Netherlands, in the countryside. And as a youngster, he was a relatively shy person, but very much interested in nature, and particularly in plants, so in the green part of nature. And later on, he decided he made some drawings, which he often threw away himself when he became older. And he was educated or enrolled, at least for some time, also as a ministry in a Protestant church. But I don't think he finished that education. But at a certain moment, but he did work in art shop or in a art trading company for some time, so he got some inspiration for paintings, but has not, as far as I know, no education in science. But I guess he learned very good to look into nature and to make creations to what he saw or what came into his mind, and put them on in paintings and in drawings. And then when he was 27 or so, he became really productive in creating paintings. And it is said that he created over 900 paintings in about 10, 11 years, because he died at 37 years old. So enormous productive. And what I noticed is that there was only one painting was sold during his lifetime. So his artwork was not that much appreciated during his life. But of course, he was very much supported by his brother Theo, which took care of him, and also stored the paintings for him.
Okay, thank you, Bert. Vesna, could you please select one question from the chat?
Yes. Yes, there is a question from Sylvain Joffrey. I can also put him or her alive, but I can read the question. If these motions are created by orographic waves, has anybody looked at the location and orientation of the local holographic structure with respect to the landscape set in the painting? This could corroborate better the hypothesis about gravity waves.
Yes. I'm not aware, I could not find that type of studies, not connected to the Starry Night at least. There are in the literature, you can particularly, by several people have studied breaking of gravity waves, even with large eddy simulation, for various relatively simple configurations of the land surface and hills. Not for these more complicated and complex situations, as far as I know, I have seen. But Sylvain, this might be something for you to pick up with your capabilities, whatever. Sylvain Joffre, yeah.
Yeah, thank. Okay,
Oh yeah, Sylvain. Yeah, no, I see a black screen now from you, but nothing more.
Yeah.
Good
Yes,
question.
something maybe I can do someday.
Okay, the following question, Vesna.
The following question is from Gerard Katz. Humans tend to see patterns where there are none. Turbulence in the inertial subrange does not have patterns. It is possible Van Gogh's spectrum has been influenced by his wanting to see patterns in turbulence.
So what is the question? Is it possible that Van Gogh, or that we actually, yeah?
Is it possible the Van Gogh spectrum has been influenced by his wanting to see patterns in turbulence?
Oh yeah, that's well possible. Yeah, but then it's striking that it fulfills the properties of turbulence, isn't it? So it's not automatically that you would then be corresponding with the properties of atmospheric turbulence. In this particular painting, I noticed, but you can see the larger scale patterns quite well, but not so clearly the smaller turbulent eddies. I'm not sure if that answers the question of Gerard.
Okay, shall we move on?
Yes, please.
Miriam Kruma, small question. Do you know if similar sky configuration of the Starry Night was recorded in real life through observations? Do you have specific dates for that?
So the question is, do we have observations supporting this in such type of terrain?
Yes,
Yes,
observations,
yes.
yes.
Yeah, there are many observations of turbulence in this mountain type of terrains, as well as simulations by Large Eddy simulation, but never with this type of, let's say, patterns which are, as far as I know, with this, where you can actually see them visible. These normally atmospheric turbulence is only visible if you do have a kind of clouds or maybe even clouds or smoke. And yeah, so in this particular case, I don't know if I'm not aware of such studies, and I could not find them when I prepared this talk. But maybe other people are familiar with that. And if so, I'd like to know. Send me a message if you like.
Okay, thank you. Following one.
Following on, Sven-Erik Greining asked, flow close to the ground, could that be drainage flow?
So I don't, so repeat this once more, Vesna. I don't, what is close to the ground?
Flow close to the ground. Could
Yeah.
that be drainage flow?
Oh, drainage flow, yes, I guess
Drainage,
so.
yeah, sorry.
Yeah, drainage flow, yes, I guess so, yeah. But Sven-Erik will know him by himself, of course. And in mountain area, like is depicted in this picture, yes. This could be well stimulated by drainage flow, which is related to the size of the hills or the mountains. Yeah.
Following, please.
But that is what this is not something which Vincent has depicted on his painting. I think he focused very much on the, or maybe here above, but that's more like this here.
Yeah.
Not, but I was focusing more upper in the sky. Yeah.
So the next one, Matthias Rotak said, thank you very much, Bert. Very interesting. Do you know whether other people have analyzed other properties, not only variability in intensity in the painting? Could be color, darkness, etc. And did people do this type of analysis also for other paintings?
Actually,
yes, you can speak also.
Yeah, so actually, in this first study by only, in fact, I think the first study also has analyzed the other paintings by Van Gogh and the properties, like in these paintings, were also analyzed and give a very similar conclusion. But for other painters, I don't know. It's not. I have not seen it. I was focusing more on Van Gogh's paintings, but I guess you can further analyze this, and by analyzing light intensity, the RGB values basically because they give you a numerical value. Yeah.
Then we have just a comment. Thank you for the presentation from Miriam Kroma. And then Branko Grisogono from Croatia said, hi, Bert, and thanks a lot for your thrilling presentation. Since you wrote that probably mountain waves breaking induced turbulence that inspired this Van Gogh's painting, would severe bora wind that inevitability includes wave breaking also produce such turbulence and the inspiration for art? I will put Branko allowed to talk. So.
Yeah, Branko, Kosovo. Yeah, so basically, in fact, this presentation should have been given to someone who lives in a mountain areas, not by a Dutchman focusing on turbulence close to the over relatively flat terrain. Yeah. Good question. So also nice to have this feedback. Any more?
No.
No. Okay.
No, at the
Okay.
moment.
Okay.
So
In
we had
fact,
some turbulent start by with this sharing of the screen, which I guess we can take out of the video when it is released on the website. And
There is one question more
okay.
from Peter Golem. Kind of related. Do you know what the spectra for other pictures which do not feature the sky? So, like the background spectrum.
I'm not sure if I fully understand what. Let's see. If can I see the picture? The question. Yeah. So I can see.
You can see the question.
Create a guest. Oh no, I cannot see all of them here.
PG, Peter Golem.
What spectrum for other pictures which do not feature the sky? So like the background spectrum. Oh, I don't know. Do you know
Peter,
what?
you can read your question loud.
Yes.
Hello, can you hear me?
yes.
I was just wondering, what does the spectrum for like other pictures which don't feature the sky look like? For example, like if you don't, for example, like a picture, if it doesn't feature the sky, can you like contrast the spectrum on the picture with the sky with the one that doesn't have the sky? So maybe it's just a feature of Van Gogh's painting, like these little.
Yes.
Like maybe not. I don't have the expertise in that, but maybe.
I guess you
did
can.
Anyone do that?
I don't know, but I guess you can do this. You can use the same analysis tool for all parts of the painting. But for the analysis which I showed, which is what, let me repeat this once more, for this particular here, only this part of the picture was analyzed. So not the village and not the cypress trees and all of that. Only the motions in the atmosphere, higher up in the atmosphere. And that, the conclusion by Finlay was that it is not fulfilling the spectral as you would see it, but I guess it's sufficiently close. There's also it's always a matter of debate on how to approximate the blue line, isn't it? So I guess it's quite close to what, and which is surprising that Van Gogh was able to do this.
No, I think the study is very, very interesting.
Yeah. So these two papers which I cited, I only try to summarize them briefly, but they are quite involved to read. You can find the references easily on the internet, and if you study them, then it will give you more background, I suppose.
Well, thank you. I think I will.
Yeah.
Thank you.
Yeah.
Okay. If there is no more question, allow me to conclude by first thanking our speaker, Bert, for his nice and presentation. It's really the spirit of these presentations to have something not usually covered in scientific talks. Yeah. And also our thank to our audience for their participation, their active discussion. And finally, I would like to invite everyone to submit ideas for further topics and or presenters for future events. Thank you all, and see you next time in 2 weeks. Thank you. Bye-bye.
Thank you.